Now in this chapter, we are going to solve quadratic function using quadratic equation. And in that, we have square root of b square minus 4ac, and that is to be calculated so many times. So we should know how to work with radicals. And this simple example will just review the skills which are required to work with radicals. Now we need to simplify this expression, which is half of square root 8 minus 1/4 of square root 96 plus 3 over 5 of square root 50 minus 9 of square root 24. Let's see how to simplify it. So let me write it once again here in factored form. So what we will do is, every term which is within the square root, we'll try to write it as product of a perfect square with that number. 8, for example, is 4 times 2, right? So 4 times 2 is 8, and we know 4 is a perfect square. So that's the idea of taking 4 here. You could write 3 2's also. Now, we'll take 1 over 4 square root of 96. Now 96 is a big number, so at times we may have to prime factorize it. So let's do it on the side. So 96 you can divide by 2, for example. So you get 2, and 2 when it goes into 96 is 448. Now 48 is 4 times 12, for example, right? And 12 can be written as 4 times 3. So that is how we can factorize it. Now, if you factorize this, you can check 4 times 3 is 12, and 12 times 4 is 48, and twice 48 is 96. You get the term 96. So you can write all these factors inside to write 96, right? So I already wrote it, so next statement I will write this. But here 96 could be written as combination of these. As you can see, we have 2 4s, so we could factor out one of them. So we will be left with 6 inside the radical. Now the next is 3 over 5 square root of 50. 50 could be written as 2 times 25 minus 9 square root of 24, which is 2 times 12. So now we will bring out the terms which are perfect squares. So we have half. 4 square root is 2. So we can take 2 outside and we get square root of 2 inside. Minus 1/4 square root of, in 96 we saw 96 as 4 times 4. So we could bring one of the 4's outside. So I'm bringing one outside, 4. And we are left with 3 times 2 as 6 inside the bracket, right? So we'll have 6 inside the bracket. Now, for 3 over 5, we have 25 square root is 5. So we can write 5 square root 2 minus 9. Now, we wrote actually 12 here. 12 really doesn't give us any perfect square. We should have written 4 times 3. So let me go a step ahead here and then show you. Sometimes if we write like this, what we need to do is write more factors. So 2 times 12 could be written as 4 times 3, right? So 4 times 3 is 12 times 4 times 3. So I further factored it, right? So let's continue with our factoring. So now we can see 2 and 2 will cancel out. We're left with square root 2 here. Minus 4 and 4 cancels out, square root of 6 there. 5 and 5 cancels out, plus 3 square root 2. And then we have minus. And here 4 is a perfect square, so we can bring out 2 and left with 6 inside. So we have minus 9 times 2 and square root of 6, right? Now, once you get to this stage, you find that you have like terms. These like terms were square roots, right? And these also can be combined. So let's put them together. Square root 2 plus 3 square root 2 makes it 4 square root 2, right? And here we have minus 6 square root and the minus sign with 9 times 2, 18. So that gives us 19, right? 6, 1 here and 18 here. So minus 19 square root of 6. So that becomes the simplified form of the given expression. Now since these two square root terms are very different, we cannot really combine them. So that is our answer. Now let's review back in this question what we did. The idea here is to write all the square root terms in terms of their prime factors or something which when multiplied by a perfect square. So it's good to know what are the perfect squares, right? For example, 5 square is 25, 6 square is 36, 2 square is 4, like that. They help you to write in the right kind of terms. But at times, if you don't get them direct, they can further be simplified. For bigger numbers, I'll suggest you can factorize them on the side so that you know all the factors, and then it's easier to find the perfect squares. These techniques help you to solve radicals, and I hope they'll be very helpful while solving quadratic equations for you. Thank you and all the best.